Alright, today we're going to do more circle problems. I know that the notes seemed okay yesterday, and then we do the homework and it's impossible, so we're going to try this again, and I think we'll feel more confident by the end of the day. Alright, let's look at the first example. Remember, the first thing you always ask yourself is, where's the vertex? So on number 1, the vertex is outside the circle. So when it's outside the circle, the angle, the one close to the vertex, equals 1/2. And when it's outside, it's big minus small. Well, they gave you the small one, so the small one is x. But what's missing is this big arc over here. And to get that big arc, we know the big and the small form a circle, so they got to add to 360. So I'm going to take 360 minus the small arc, so that's 360 minus x. So the big is 360 minus x, and the small is just x. Okay, so now simplify. And this one you don't need to clear the fractions because you can easily take half of everything. Okay. And then subtract. So you get negative 125 equals negative x, so x is positive 125. Alright, let's try this example. Example 2. The vertex is inside the circle, but is most definitely not on the center. So when it's inside the circle, the angle, that's ever closest to the vertex, equals, when it's inscribed, you have two intercepted arcs, and you're going to take the average of the two arcs. Well, one of them was 29, but they didn't give you the other one. What we do know, however, is that we have a diameter. Now this is a diameter because it goes to the center. The other one is not, which means these two have to add to 180. So we can figure out what this arc is by taking 360 minus 83. And, not 360, just kidding, 180 minus 83. Sorry. That gives you 97. Okay, so now add them together. 29 plus 97 is 68. So we get half of 68, which is 34. Alright, next example. Example 3. The vertex is outside the circle. So when it's outside the circle, the angle, which is 18, is 1/2 the big arc minus the small. Well, if I'm looking at the two intercepted arcs, the big arc is always furthest away, but it's pretty obvious to see it's 102, and the small one is x. So get rid of the fraction, multiply by 2. So I get 36 equals 102 minus x. Subtract the 102, and we get negative 66 equals negative x, so x is positive 66. Example 4. Vertex is on the circle. So when it's on the circle, the angle, which is 3x plus 27, equals 1/2 of the intercepted arc. And this is the intercepted arc, which they didn't give us, but we can find it because we can take 360 minus 150 and get 210. Okay, clear the fractions. So over here we get 6x. Oh, we don't need to clear the fractions. Let's not do that. That's not necessary at all on this one, because we can take half of 210, can't we? Alright, so half of 210, so we could say 3x plus 27 equals 105. 105 minus 27 is 78. So we get 3x equals 78. We divide by 3, and x is 26. Alright, let's look at example 5. This angle right here, its vertex is on the circle and formed by two chords, so it's half of its intercepted arc. This angle right here, its vertex is on the circle and it's formed by two chords, so it's an inscribed angle and it's half of its intercepted arc. Well, if these two angles are half of the same number, And they know they got to be equal. So 5x minus 19 equals 2x plus 8. So we get 3x equals 27. So x is 9. Alright, let's look over here. We want to find x. Well, the vertex is outside the circle. So x is going to be 1/2 the big arc minus the small arc. So here is the small arc. And here is the big arc. Well, we don't need either one of those things, so we need to do something. Now look at 72 though. Its vertex is on the circle and it's formed by 2 chords, so it must be an inscribed angle. So it's going to be half of its intercepted arc. That's a small arc, so that's good. So we take 72 equals 1/2 of the small arc. We'll multiply by 2. That means the small arc is 144. So that's that. Now we got to find the big arc. Well, the big and small form a circle. So 360 minus 144 gives us 216 for the big arc. And now we can finish the problem. We have 1/2. 216 minus 144 is 72. And half of 72 is 36. Okay. I know we did one like this really fast in our notes last time, so let's see if it's better this time. First of all, before we start, look for a diameter, because anytime we have a diameter, it splits the circle in half, so you get 180. So that means 104 plus AD has got to equal 180. So this is 76. And then on the other side, 132 plus DC, it's got to equal 180. So DC would be 48. All right. Now let's fill in some blanks. The measure of arc DC with 2 letters, it's the shortest distance between the 2 points, so we already know that's 48. The measure of arc AD, 76. The measure of arc BEC. Well, if I'm looking at this, B to E to C is this angle here. So the vertex is on the center. It's formed by 2 radii. It's central. So that means the angle here matches the arc. So this is 132. Now we want angle DEC. So if I'm looking at D to E to C, oh, that's another central angle. Vertex on the center, formed by 2 radii. So the angle matches the arc. So that's 48 as well. Now we want BDC. So from B to D to C. Well, its vertex is on the circle, and it's formed by 2 chords, so this angle is going to be half of the intercepted arc. Well, this is the intercepted arc, so it's going to be half, whoops, not 1/3, just kidding, half of 132, which would be 68. 68. Now they want DBC. Oh, D to B to C. Okay, well that's another inscribed angle because the vertex is on the circle and it's formed by 2 chords. So this angle here is going to be half of its intercepted arc. So this one's going to be half of 48, which makes it 24. Alright, more fun. Now they want DCB. So D to C to B. Well, it's an inscribed angle also because its vertex is on the circle, so it's half of its intercepted arc. Its intercepted arc is this semicircle, right? So it's going to be half of 180, which would be 90. Alright, now they want ECB. ECB, E to C to B, is this angle here. Now you've got 2 options. In triangle BEC, you know 2 of the 3 angles, so you can subtract and find the 3rd. But you also know in a triangle the radii are congruent, so this has to be equal to this, which means it's isosceles triangle. So this angle has to be 24. Alright, last but not least, they want ABD. A to B to D. Well, it's formed by two chords, and the vertex is on the circle, so it's going to be half of its intercepted arc. So it's going to be half of 76, which would make it 38. Alright, let's look at this example. Example 8, we need to figure out the value of x. Well, we know all of these form a circle, so they got to add a 360. So we have 120 plus 2x plus x plus 2x equals 360. So we get 5x equals 240. So x is 48. So now you know this is 96. This is 48. This is 96. Okay, now find whatever combination they want. AB, shortest distance between the 2 points. It's 96. BD, shortest distance between the 2 points. 48. AD, well, that's the combination of 96 and 48. So it's 96 plus 48, which would be 144. Then we have DEA. So that means you're going to start at D, go through E, and add at A. So that's the combination of 96 and 120. So we add that together and get 216. Alright, last but not least, they want ACE. So start at A, go to C, and then end at E. So they want this angle here. Well, to get an angle, the vertex is outside the circle. So our angle is going to equal 1/2 of the big arc minus the small. Well, the big arc we know is 120, and the small arc we know is 48. So 120 minus 48 is 72, and half of 72 is 36. Okay, now I want you to stop the video, and I want you to spend some time working on the next worksheet and figuring out what the answers are. Then start the video again to check it. But be honest, try it once. Okay, let's look at these answers and see how you're doing. Number 1, remember, if there's a quadrilateral inscribed in a circle, then the opposite angles add to 180. Okay, number 2 is a little tricky because you can't find x, because to find x you need this or this. So what I did was find y. I found y first by using these two angles and got y to be 58. And once I knew that, x and y are a linear pair, we can say x is 122. 3, vertex is on the circle. So 5x is going to equal 1/2 of the intercepted arc. So I multiplied both sides by 2, so I got 10x equals 9x plus 20. Okay, over here I didn't show my work for some reason. So the angles outside, so 68 equals 1/2 the big arc minus the small arc. The small arc is x. The big arc is 360 minus x. There's your equation. Alright, number 5 is tricky. Okay, because you got to remember your algebra. So here the vertex is outside the circle. So that angle, x plus 2, equals 1/2 the big arc, x plus 70, minus the small arc. Okay, so first of all, let's get rid of the 2's. So if I clear the fractions, the nice thing is they clear on both sides. So this just gives me x. Now over here, when you subtract a parentheses, you're subtracting everything in the parentheses. So you got to change the signs to everything. So we have positive x and negative x, they cancel, and positive 70 and negative 30, and that gives you 40. You got 100 for your answer. You didn't change the sign of everything in the parentheses. Okay, over here we did one like this in our notes. Since this angle was inscribed, it's half of its intercepted arc, which makes it 140. And then you can subtract the 2. I'm going to pause it.